Good afternoon. I'm very excited to be here, and I'm excited to share these ideas with you. And what I'm about to tell you arose in a classroom. So imagine, I know there's a lot of students sitting out there, imagine sitting in a classroom and actually learning something that you can apply to the real world. That was a joke. This actually happened. So I can tell you now that when we come to talking about how cities can turn themselves around and behave like ecosystems rather than parasites, I will give you the mechanism for which that can happen. And it's called vertical farming, farming right inside the city. So let's begin with a discussion of what the issues are that face us all today. And food safety and water safety and availability are the big questions facing literally half of the world, perhaps even more than that. Reducing our dependence on fossil fuel is a given. Everybody wants to do it, but we just can't seem to do it. And then, of course, there are the damaged ecosystems that we have created by our farming practices and by encroachment into the landscape from the city itself into suburbs. The causes of rapid climate change, which we have partially caused, are those greenhouse gases that we have produced by burning those fossil fuels, and at the same time the deforestation to make room for our farms. So if you take away the carbon sink and also produce more CO2, this is what you get. And so as Bob Bishop told us, we need to start modeling all of this to see how that all plays out over time, so that everyone can see the big picture from afar and say, oh my goodness, that's really what's happening. So in order to know how to proceed, you have to be able to imagine what it was like to live 15,000 years ago. That's not so long ago in terms of geology time, but of course it is from my perspective and yours as well. But 15,000 years ago, there were no farms, there were no cities, and maybe 1 million people living on the planet. And all of a sudden, what happens? All of this yellow that you see on this map was generated by Landsat photographs from NASA and managed by a group up at the University of Boston University, rather. All of the yellow color is farmland. If you put that all together, for 7 billion people, our agricultural footprint comes out to the size of South America. That's not acceptable because there's an additional 2 South Americas in grazing land that we also take from the earth to use for our food production. This has created huge problems for everything because it's all connected. So agricultural runoff, which is our biggest non-point source pollution, goes into the estuaries and kills off all the larvae of all those nice crustaceans and mollusks and fish that we've come to rely on for our other food supply. And we've trashed the oceans. And not only that, we're changing the pH of the ocean also. So we have some real issues to talk about. We've had terrible floods. And the population, of course, everybody's emphasized this, but I will too, because it plays into what I want to tell you later. We're going to have another 3 billion people, perhaps. And those, even if we had enough food now, and everybody agrees we do, we just don't get it to the right places for the right people. That's going to get worse as time goes on. So if 7 billion people need this much land, then another 3 billion people will need the size of Brazil. And I'm sure if you ask Brazilians whether they're willing to give up their country for the next 3 billion, they would probably say no. So what are we going to do? If this is how much land there is, and this is how much we already use, you know that there are problems in the near future. Not only that, 20 years later, 80% of us will be living in cities or surrounding suburbs. So we're urbanizing like crazy, and we really don't know how to live in cities. Cities, as we've learned by the introduction, are parasitic on the landscape. They eat lots of resources, some of which we know about, others we don't track as well. It's the black box that everybody's afraid of analyzing, and all the wastes come out. And although agriculture over time has created a wonderful environment for 7 billion people, we use 70% of the liquid fresh water on the planet. We now use fertilizers and herbicides and pesticides to make our crops grow in a non-ecological setting. And in the United States, at least, we burn 20% of our fossil fuel just for farming purposes. Sure, we get our food. We also get this runoff problem. So, my question to you is, does anyone out there disagree with this statement? Because if you look back in time, all of the cities of the past weren't sustainable either. They're not here in that present situation. So here we have the question of all time, I think. Can we supply enough food and water for 10 billion people? But we have an and the and is we need to repair the damaged ecosystems at the same time. We have to do both of those things. Because if we don't, in 50 years from now, even though we can grow enough food to feed another 10 billion people, there will be no more land left to supply ecological services for our health. We need those ecosystems to function. So, inspired by nature, we take our lead from nature's grandest design, the ecosystem. In undisturbed environments, and there are some still out there, nature behaves as it has for as long as there's been life on this planet. As long as we've had ecosystems, we've had nutrient sharing, nutrient cycling, conservation, selection for the most fittest, most efficient life forms. You've heard this morning, we are very, very good at efficiencies for our own lives. We can use science for this purpose, so why don't we just do that? And that's what I'm suggesting. We should do that. And in doing that, we can be diverse, we can be efficient, we'll certainly be balanced, and if damaged, we can recover. We will be truly sustainable. Sounds Pollyannish. Here we go, creating the eco-city. The eco-city produces food, and it uses in-house food production centers to do it. No ecosystem is definable unless you define bioproductivity. A city, if it's going to behave like an ecosystem, has to produce its own food. Not all of it, but a lot of it. We have the tools, and we have the desire to do it. And this is the result, soilless farming. And I know a lot of you are sitting out there saying, oh, it's about hydroponics, it's about tasteless food. No, it's not about that at all. But I can assure you that we can make food taste good regardless of where we grow it. So the taste is not the problem. The advantages of having a vertical farm is that no agricultural runoff occurs. We get year-round crop production. We can save our crops from bad weather events because they're all grown inside. We use 70% less water because it's hydroponic. And above all, we can take the land that we're not farming outside and return it to the ecological functions that it had before we started to farm. But there are more advantages too. We can remediate gray water that we create ourselves. We can create new jobs. Every mayor of every city loves to hear that one. We can supply fresh produce for people living in disadvantaged areas and food deserts, etc. We can use abandoned city properties. I'll tell you about one at the end of this presentation. And finally, we can grow things that are not food-based. We can grow biofuels. We can grow drugs in plants. We can make them do things for us. Plants are versatile. Every indoor acre of farming generates 10 outdoor acres of land that we could let return to nature to restore ecological functions and services. So the eco-city will look something like this to begin with. Urban farms produce the food, we produce the byproducts are then recycled back into the urban farm. It's not a pipe dream, it can be done. Here are two places that are already recycling all their gray water back into drinking water. A lot of other places too. So where are these vertical farms, you say? Are there any to talk about? If I were to show up at this TEDx conference 3 years ago, I would have said, there is one planned for, but today I can tell you about some. All these red dots that some of you might be able to see are, and they've moved, look at that, those dots have moved. That's an interesting product of electronic technology that I didn't expect. But let me just show you where they are rather than, I'll tell you where they are. Here's one in Korea. It's funded by the government, and it's a 3-story structure, and it produces leafy greens, but its purpose is to demonstrate the possibility of indoor farming. I had the pleasure of visiting that one. Here's one that's operative in Kyoto, Japan. It's the size of a 747 hangar, and it's huge. It grows lots of food inside, and it's a commercial venture. Here's one that recently was established in Singapore. It's 4 stories. It uses sunlight for its energy source. It uses soil-based agriculture to produce plants, and it's continuous grow year-round. Here's one that just went up last year in Vancouver. It's 4 stories tall over an old parking lot. Nobody needed that parking lot, so they took it. And here's one that's going to go up in Sweden. It's 14 stories planned. It's a mixed-use building. It's offices on one side, the farm is on the other side. Imagine going to work and saying, okay, it's time for lunch. I think I'll go out and pick it. No, I don't have to go out. I can just pick it. Another operative farm is in Chicago. It took advantage of an old meat smoking plant, the bacon and ham smoking plant, abandoned ship because of the economic situation in Chicago, leaving this beautiful building available. This guy moved in, John Adell, and reestablished urban farming, which used to take place in Chicago back in the early 1800s. He reinvented it. And finally, there's a vertical farm going up in, of all places, Jackson, Wyoming, where the average income exceeds this entire room. Why would they want to put a vertical farm in a place like that? Because they have lots of migrant workers that show up every summer, and in the wintertime, they stick around because they have nothing else to do. Here's a wonderful opportunity for them to continue to work and be productive. There are other available vertical farms on the horizon. The one I would like to share with you right now is the one I learned about last week, but after I had submitted my slides, of course. It's called Farmed Here. Isn't that a great name for a vertical farm? Farmed Here. It's 90,000 square feet of indoor space. It's about the size of this auditorium, growing all kinds of vegetables commercially, available to the supermarkets or whoever wants to come and buy from them. So in conclusion, I think that we can turn a parasite into a mutualistic symbiont, the city, by showing it how to be bioproductive. Urban farming is a big deal now. If you look around the world, everybody's trying it. And I'm sure we're going to succeed too. So we should be smart and farm smart. And if we do that, we'll save water. And if we do that, we'll save land. And saving land lets us give it back to nature. And then in doing so, we can live sustainably. Finally, we can help our blue planet green up. Thank you.